this onto his arm, but...
All right, this video is for the 5.3 homework. This is quadratics in the real world, okay? All right, a soccer ball is punted across a field. The height of the ball in feet can be modeled below, where x is horizontal distance traveled in feet from the point of impact. Okay, typically these are projectile motion is what quadratics are. And so if we're talking projectile motion when it comes to a quadratic, right? The number in front of the x squared is the effect of gravity. It's negative 16 if you're talking in feet. It's negative 4.9 if you're talking in meters. And that's an always kind of thing. The x is the speed at which you launch, kick, throw, whatever the projectile. And then c is the height that it starts off the ground. So like Keegan throwing a football, right? I could write a quadratic to represent Keegan throwing a football. Okay, so we would probably say in feet. So it would be something like negative 16 x squared. Keegan, how fast do you think you can throw a football? 80. I can throw pretty hard. So if you like, let's say 50 miles an hour, right? So okay, so let's do this because it's gotta be feet. It's gotta be feet. So let's say 20 feet per second, right? 20 feet per second. So plus 20x. And then Keegan, how tall are you? He's 6 foot. So plus the 6 feet off the ground. That quadratic represents Keegan throwing a football.
Wait, that'll tell us how far he throws it?
That'll tell you everything.
Wait,
that'll tell you the maximum height that it'll reach. That'll tell you the time that football will hit the ground. I mean, same thing. When it will hit the ground, how far it would go. So let's look at it. But again, this is hypothetical if you're throwing at 20 feet per second, right? Okay. So if we graph this thing, so negative 16x squared plus 20x plus 6. There's the quadratic that represents this, right? So how far it goes, right? That would be a 0. So this says 1.5 feet. But again, these are hypothetical numbers. These aren't legit numbers. I bet our speed is way off, is what it is.
Doesn't it matter like how high up you throw it? Like I don't understand how that equation works.
The angle that you throw it at, we're not concerned with that when it comes to quadratics.
So you can throw it like straight down?
Well, no, it's saying if you launch it from that position into the air.
From 6 foot, so like a head.
So that's not Keegan throwing a pass exactly straight. That's Keegan just launching it up into the air as hard as he can. Okay. Keegan, do you want to know how high you could throw that ball?
Sure.
All right, let's see. So that would be the vertex. You could throw that ball 12 feet into the air. But again, we're talking 20 feet per second. So that's not very hard. Okay? Anyways, we use these quadratics in the real world for stuff like this. All right, so this one's talking about a soccer ball. Okay? It says, what's the maximum height of the punt? So what I would do is I would graph this quadratic that they gave me. Now, your calculator is kind of finicky with parentheses. What math is happening when I have a number shoved up against parentheses? So sometimes when I type this in the calculator, I have to put that assumed multiplication symbol in there. I worked one today on your notes that happened. It wouldn't take it. So we're going to see if this one takes it. It happens more often when it's like an X is out here and an X is on the inside, that you have to put that assumed multiplication sign in there.
This Wi-Fi needs to get its crap together.
Wi-Fi's working. Oh, are y'all still not working on Wi-Fi? How on earth are we going to take a midterm?
Connect to your hotspot on your phone.
Yeah, that's the only thing we're gonna have to do. Like, we're not gonna have a choice. Okay, so what would the maximum height be? If we're thinking about a quadratic, what part of the quadratic? Okay, so which part of the vertex?
Y.
The y. So the y would be the height. The x would be the time that it takes to get to that maximum height. So I'm going to zoom out on this. Menu 4, 4. Okay, so vertex is a maximum. So menu 6, 3. And there's my vertex. So the height is the y value. So the highest it's going to go is 121 feet. Horizontal distance. What would the horizontal distance be?
Oh, you gotta do like the 0.
The 0. This is like the actual picture of this kid kicking this soccer ball. Here's where she kicked it. Here's the highest point it reaches. Here's where it hits the ground. So the horizontal distance is going to be from 0 to here, and that point is an x-intercept. So all I have to find is the x value of that x-intercept. So that is menu 6, 1. Menu 6, and it's called a 0 in here. A 0 and x-intercept, those are all the same things. So 220, that x value, right? Isn't it feet? Yeah, it's feet.
Oh, actually.
Wait, isn't it asking?
Yeah,
it's
that's
maximum
asking to
height.
That's
not
probably
velocity.
Yeah.
Oh, what is the horizontal? Oh, I see what it says. I didn't see the rest of it. What is the horizontal distance to the ball traveled to get its maximum height? So that is this value, the x value here. So 110 feet. If the ball was punted from one end of the field, how far along the field in feet did the ball travel when it reaches the ground? That's what we just found. That's the 220 feet. That's from where we kicked it to where it lands. Okay. Divide it by 3. It's like 73 1/3.
Y'all are both wrong.
All
Well, I had some left over. But
right. If air resistance is ignored, then the formula S of t equals negative 16t squared. So there's that gravity constant. Plus original velocity. V of O stands for original velocity, original speed. Plus H of O, original height. Calculates the height, S, of the object above the ground in feet after t seconds. If a baseball is hit straight up with an initial velocity, V of O, of 80 feet per second, or about 55 miles per hour. So again, that kind of shows you the comparison there. So for Keegan's, that's probably where we should have put it at, was more 80 than 20. And leaves the bat with an initial height of H of O, original height of 3 feet. Write a formula that models the height of the baseball after t seconds. So S of t. We don't use S's in math because a lowercase s, what number does that look like? We don't use S's in math. Okay.
kind of like a 2 and a Z.
Yeah, why I cross my Z's. Because Z's look like 2s. 7s are the same way because 7s look like 1. Okay, anyways. So, gravity velocity, or the gravity constant it's giving me. Original velocity is 80. And that's the B value. So there's a T that goes behind that. And then the constant is the height that it starts, plus 3. All right. How high is the ball after 2 seconds? So we can graph this and we can find everything that we need. Now, you could plug a 2 in there for that T and work it out, right? In your calculator, you can't put T's. So if you write your equation with T's, if you type it in the calculator, you have to do X's. Okay. 2 seconds. Is that going to be an X value or a Y value?
X.
So I'm looking for when x equals 2. You got two options here. You can pull up the table, Control T.
So that'd be f of 2 equals.
It would be s of 2.
Oh, s.
So it would be something like s of 2 equals negative 16 times 2 squared plus 80 times 2 plus 3. That's how you would work it out by hand. All I have to do is on the table, Control T pulls up the table, go to where x is 2. So the baseball is going to be 99 feet high. The other way that you can do that, if you know the x value, on here it's called trace. And that's menu 5-1. You type in the x value that you know, x is 2, and hit enter. And then down here it gives you that ordered pair. When x is 2, y is 99.
What do you have to put to get that?
That, okay, so table is Control T. Trace is menu 5-1, but you have to know your x value. You can't, there's not a trace for if you know the y value. Okay?
There should be.
You can find it on the table. All right, find the maximum height of the vertex and how long it takes to reach the maximum. So again, that's the vertex. So to find the vertex, if it's a max, it's menu 6-3. You have to be able to see the vertex. So menu 4-4 zoomed out. You have to be able to see that vertex before you can do this. Menu 6-3. Capture that maximum. So that vertex is 2.5, 103, which means the max height, ooh, if I could spell, is 103 feet. And the time to the max height is 2.5 seconds. The real world context is why I love quadratics.
Yeah. Makes it more interesting.
I agree.